Yes, hello everyone. As we established, my name is Paul Coulson and I'm the Director of Operations at the Institute for Fisheries Management. I'm going to start proceedings this afternoon with a talk around creating balanced fisheries and looking at some of the ways we can use aquatic vegetation and habitat enhancement to create a more sustainable, more balanced and ecologically sound fishery. I'd just like to thank at this point Tim Pankhurst of Plant Life and Dan Holm of the Institute's training team, both who contributed some slides and some information to this presentation. So it isn't all my own work, and we'll pick out some of Tim and Dan's slides as we go on. So a bit of an overview to start with. So I'm going to kick off with let's not panic. Yeah, so a bit of some of the questions that we often get around plants and plant management. Then we're going to have a brief introduction to native plants. I look at the different plant forms and types, and then we'll finish with some of the benefits of aquatic plants. I'll try and get you to understand that there is value to having them in your fishery in manageable quantities. So some questions then. So why are you attending today? So we often see this. Our waters are overrun with weeds, and we want some help and some guidance on managing them. We keep losing fish. Our anglers are moaning about fish and being able to access them. We've tried everything to get rid of it. It's often a cry we hear. We've tried, and then just add any number of management strategies in there, and they're not working. And we even get the real sort of desperate end of it. We're thinking of draining the lake and starting from scratch. Yeah, and we know with some of the problems we've seen, it certainly is in people's minds to what can we do to get rid of it, particularly where we're talking about some of the more invasive plants out there. And certainly as well, obviously, our fish are uncatchable, or our anglers or our members are telling us our fish are uncatchable. There's too much plant life. It's too difficult for them to target the fish. Which obviously isn't always the case. And then we often say that we need any aquatic plants anyway? Why don't we just nuke the lot of them, and we'll start with a blank canvas, and I'm sure the fishery won't suffer. Well, and we can tell there's lots of problems, and everybody's trying to or is pulling their hair out with this. So. And I'm sure some of you have sort of seen this with regards to algae. We'll win, we'll fight the algae, we can beat it. Well, in reality, if you take your eye off the ball and you're not treating the causes of the enrichment, that's firing the algae up, or you make a preemptive strike to treat it in advance of it becoming established, this is what you could be faced with. And obviously we're going to look at algae in more detail in a minute with Bernice, so I won't major too much on that, but it's just to say, this is what can happen. You need to be aware of the causative agents of particularly around algae and algae blooms, and how we can manage it. So we'll start off with a bit of an introduction to plants, and a thank you to Tim Pankhurst, as I say, Plant Life. For the next few slides, they all came from a presentation that he produced for us for last year's weed workshop, the one that we would have delivered face to face if we would have been able to. So roughly 151 species of native aquatic flowering plant in the UK. So there's lots of them. There's lots of different types. There's lots of different forms, be they submerged, free floating, emergent, and I'm not saying anybody's going to be an expert on all 151 of them. Obviously, there are people who are experts in all 151 of them. I'm certainly not one of them. And you're going to see many different types within your waters. And it does, it does take quite a bit of work to get an idea of what's what. And to add to the list, and to muddy the water somewhat, there are also now 29 alien species of aquatic plants. And again, I'm sure some of you have come across this, or you've seen reference to them. The one in the picture here is New Zealand pygmyweed, or Australian water stonecrop, as it's also referred to. A highly invasive alien species, will rapidly colonize waters and given the right situation. But we can also add into there other ones, floating pennyware, azola, the curly waterweed, Lagoriciphum, Canadian pondweed, some of the ornamental lilies. Then you've got the marginal plants, haven't you? The Himalayan balsams, the giant hogweeds. So there's lots of alien species that that are certainly getting a hold, and many more that we might see with climate change. So in all, we're looking at roughly 180 species of aquatic flowering plant that may appear in waters that we may frequent. We need to add into that again and muddy the water somewhat more. There are 41 different hybrids. So we could be looking at 221 taxonomic entities of aquatic plants. If you want a comparison, if you was to look at freshwater fish, in the UK, we probably get 50 freshwater fish, of which only 41 are native. So we're only dealing with a much smaller sample size when it comes to fish. So when it comes to fish ID, it's a much easier task to actually get an accurate ID of them. And if you want to look at, I'll give you an example here of how complicated it can be. If you look at this slide here, and that's the pondweeds, potamogetons. If you showed that to an angler, he would say, yeah, that's potamogeton, and he'd get a fairly accurate identifier of it. However, there are 21 species of potamogeton. There are 27 known hybrids, most of which look pretty similar with some edge leaves, but they are, you can drill down into the information. So some of these particular niches that they live in, they're either the still water or flowing water, and they can also be particularly long-lived. So what this is showing is that even when we think we know what the plant may be, until you actually look at it in a lot more detail, it's very difficult to actually get an accurate identification. Just to flag up as well, there are 30 species of stoneworts in the British Isles. These are actually desirable algae. They're a very ancient group of aquatic plants. A complex form of algae. They look similar to higher plants rather than that free floating green soupy mass that you may have come across. Well, you may have more common with the common algae. But the importance of stoneworts is the majority of them are now quite rare, and we've lost a lot of them or lost a lot of their habitat due to water pollution. They do like very clear, clean waters. So this is something we want to flag and want to make people aware of. Is to, if you see anything that you're not quite sure of it, and let's make sure we get an accurate identifier of it, and we can see what it is. So freshwater plants, around 8% of the UK flora. However, they're growing in 0.001% of the land area. So we've got 8% of the plants growing in a tiny, tiny fraction of the land area of the UK. And if you want to look at this, the Lake District, well, the Lake District is actually only 3% of the Lake District is open water. So even then, even within an area that you would think, oh, well, it must just be a massive open water. Actually, even a tiny fraction of the Lake District is open water. So we've got a good percentage of the UK flora living in a tiny, tiny percentage of the land area. So when we're looking at aquatic habitats, extraordinarily varied from the images here, where you've got images or where you've got a small babbling chalk stream, and we all know about chalk streams, very rare environment, of which the vast majority of them are in the British Isles, or certainly within England. Very natural, very dynamic, very rapidly changeable systems, and they are a significant focus for our biodiversity. They support massive amounts of life, both aquatic and terrestrial. So they're an incredibly important habitat type across the United Kingdom. If you look at this picture here, you could quite easily pick out a dozen, 15, if not more species. So you can see how even in a very small area, you've got a very diverse range or mix of aquatic plants. So if we look at those, a variety of growth forms. So they can be free floating, but within that free floating, we can have submerged or fully submerged or plants with floating leaves. And then we can have those rooted plants with their emergent leaves, so your bulrushes and your Norfolk reed and your flag iris and the like. So lots of plants, lots of forms and types, and lots of different areas and habitats that they frequent. So let's have a look at that in a gram in relation to a standard fishery. So we can see in here, it's just a rough sort of cross section through a pond, and we can start to see those various the zonation of where these plants inhabit. So marginal plants and emergent plants, which we've which are quite common, and I'm sure you could go walk around your fisheries this afternoon and see and pick out these quite easily. We have our floating leaf plants, our lilies, our potamogetons and things. And we move further down into the submerged area under the water. We start to see our submerged aquatic plants, things like your milfoils and your Canadian pondweed and the like. So this is just a diagram I actually scanned out of quite an old book now. So it's again Wildlife Conservation Trust book about turning gravel pits into wildlife havens. And you can see on here those clear bands of clear areas which each of these plants like to inhabit. We start from the purely terrestrial and we go right through into this, what we call that aphotic zone, where it's there's no light, penetrates down deep enough, so we don't get any of the higher plants in there. So really, the driver here is the light. How much light can we get to get down? In the majority, you'll note on here, you'll see on here. Look, that photic zone is 11 meters in very clear water. I would suggest in the majority of the waters that you guys are managing, anything below 3 meters, 4 meters in most lakes, just simply due to the amount of suspended solids that we get, the murkiness of the water, which prevents that light penetration, and as a result, it prevents plants being able to photosynthesize, and it prevents them being able to grow. But doesn't mean, it's a sweeping statement. I'm sure that some of you have got very, very good, very, very clear gravel pits and the like, and you'll get plant growth going much deeper than that. But generally the limit would be 11 meters. And if I was pulling weed up on fisheries in sort of 10 meters, I'd know it being in very, very clear water. So just an example here of those sort of rough categories that we can expect to see the various forms sort of established in. So just going to have a quick whistle stop tour of some of the plants we can hope to see in the different areas. So marginal emergent plants, those that you see at the water's edge. Common ones often is watermint and water forget-me-not. I mean, watermint is easier to identify. If you grab a couple of leaves and crush them between your fingers, you'll get that quite obvious minty smell. And then water forget-me-not, that pretty little blue flower. And then we sort of move on, and there's lots of others. This is just really just an example of some of the forms you can see, some of the plants you can see. Marsh marigold and lesser spearwort. So you can start to see another point here with your marginal plants or emergent plants is you get some colour. So they're a nice way to add a little bit of colour to your fisheries and add a different sort of aesthetic appeal. And we particularly see that with the next plant. So where you can see here with yellow flag and purple loosestrife, they've got that nice, and then there's those nice coloured big flowers. But also what they're adding in here is not only is it that aesthetic appeal for anglers and creating a nice environment, you're also creating a beneficial habitat for invertebrates and areas where aquatic invertebrates can come out of the water and hatch and things. So you're adding an extra benefit by having these plants there. And they're also, particularly with like some yellow flag, they're quite a solid plant, so they can be used nicely to add some structure to your margins and to mark out areas or create a bit of isolation, if you like, between angling pegs. So moving out a little bit into the water. So yeah, so floating leaf plants or these rooted floating plants. So again, another form here, another form of Potamogeton. There's broadleaf pondweeds and the starworts. So again, right plant, right place is a mantra here. Pondweed will march and will establish themselves much deeper than sort of 1 to 2 meters. So we do need to be aware of that. And again, it's something that anglers often will target fishing, but they'll also moan when it becomes established that it's become too dense and too difficult to fish in. Some of the more sort of the other pretty plants, if you like, and we've got the native lilies here. You've got the white water lily and the yellow water lily. And if I was going to say anything about water lilies, make sure you're using the right type. We're not buying them from garden centres and throwing them in because they've got nice pretty purple flowers and we think it'll be attractive, because that's often going to be the cause of some of your problems. Yeah, lilies, lots of benefit here from having lilies, but again, they've got that nice, the nice colours and they bring something a little bit different. But they also provide lots of benefits for fish. They provide important shade. They can regulate water temperature. So there are benefits to having them, but again, need to be right plant in the right place. So submerged plants, your milfoils, your hornworts. You can bring in other submerged plants in here as well. So your invasive plants like your Lagerosyphon and your Canadian pondweed would be one. But again, lots of benefits to having them. Can become problematic, so they do require you to be thinking about how you're, where you are and how you're going to manage them. But certainly, the benefit for fish, for spawning, for juvenile habitat, for invertebrate habitat as well is great. So it is well worth considering having or managing and controlling it, but having some of these submerged plants in there. And so the last group then really is our algae, these cellular, lower, simple plants, no distinguishable leaf, free floating in the water. Often as we see them, and if you look on the next slide, you'll see anglers refer to them as sort of pea soup, or the water's got that pea soup colour. And as you can see from this this ornamental fish poking its orange head out of a green bowl, they can be a real problem. Once they become established, it can be a real challenge to manage them. And we've obviously got these two types. We've got this filamentous, this attached branched algae, of a blanket weed type that anglers will struggle and fish will struggle to navigate and fish through. And then we have this single cell, this free floating form that creates these green water conditions. And it's not by any stretch a problem of purely of still waters. If we look on here again, you may have seen this earlier in the year. At the back end of last year, this is a problem on the River Wye that was brought to people's attention by the Wye and Us Foundation. And this is excessive nutrients flowing into the River Wye from their catchments. And you can see exactly the same area of river. You can see on the left here, you've got the ranunculus beds, the water crowfoot beds, these really lovely habitat, lovely white flowers, all creating lots and lots of benefits for the river, and particularly for the fish and invertebrates. And on the right, exactly again, the same area, and you'll notice that there's nothing there but this green, horrible algae water. And the causative agent here was from free-range chickens being found openly in the Upper Wye. Poor management of the land. We all think, free-range chickens are great. It's not battery farming. It's better for the chicken. However, if the land use isn't particularly well managed and there's heavy rains can drive the nutrients off the land and into the water, it flows into the river. A bit of heat, bit of sunlight, massive nutrient load, and we get the knock-on effects is this algae-dominated water, and it has obviously detrimental effects on the higher plants that would be there. So, benefits of aquatic plants. Are there any? Yes. Aren't they just a pain? No. So, let's have a look at some of the benefits of having aquatic plants in our waters. So this is just a diagram that we use for a lot of our workshops and things, and really at the centre here is that good fisheries welfare. We want to promote good fisheries welfare, and you can see all of the bits here that we need to be concerned about for improving and providing a suitable habitat for our fish. So I won't go through each one, but basically with your aquatic plants, you're providing good habitat. Obviously, you're putting some shelter in there. The invertebrate load grade planted fisheries, so you've got nutrition, and it helps with water quality. So we'll touch on all of these in a little bit more detail. This is an old fishery management diagram taken from some work by Ian Cowkes a few years ago. Basically, we're looking at the carrying capacity of the water, and the amount of fish your water can hold is dictated to by the quality of the habitat, the amount of nutrients, which therefore generates food availability, and obviously the amount of space you've got available. But basically, the greater the amount of plants and algae that are within there, the greater the amount of invertebrates, and the greater the invertebrates, the more roach you can sustain, and as a knock-on effect, obviously, the more predators you can sustain. And in this example, it's pike. Yeah, and so you can see that it's just a diagrammatic way of getting you to understand that there is some benefit to having some plants and algae in there, and how it can support the fish in your waters. So very quickly, let's rattle through a few points here. So spawning, fish require somewhere to deposit their eggs. Most coarse fish eggs are sticky and attached to submerged plants. And I've just taken an image from some of the great work that the Avon Roach projects are doing here to show how they've put artificial habitat into the Avon and to encourage the roach to spawn. So you can see where you haven't got that suitable habitat, even if you add something artificially, fish will home in on it and use it to spawn. And in the example of the Avon Roach project, they take those out and then put them into ponds and grow them on artificially and put them back. So you can see it's something you can consider in still waters as well. We've seen them being used on some of the big industrial canals in Yorkshire, as well as to try and generate some habitat. Obviously, coming from there, you're going to get some juvenile fish. And so we need some habitat for those juvenile fish, and their preferred habitat is shallow, warm water. It warms up quickly, has some a food source in there, but also has some shelter. So so having those reed beds and the stems where the juvenile fish can get in and away from predators, warms up quickly and provides them with a safe haven to grow and to develop. Refuge, important. If you remove all of your plants, where do your fish go? All right, this is an ornamental back garden pond. Don't shout at me about the ornamental lilies. But it's just to show, fish need some shelter. They need some shade. You need to keep them there. They want to be out of the sunlight. They want to get away from anglers and from predators. So having some shelters and refuge in there is also really important. And as I said, yes, anglers want to catch fish, but fish become stressed when they're constantly chased 24/7. So providing some areas where those fish can get out of the way, they can have some shelter from angling pressure is also valuable to the fish. Yes, you might think, well, we'll increase or improve the angler experience by just having a bowl full of fish, but that's not great for fish health. It's certainly, all right, each to their own, but it's not an environment I would particularly want to be fishing in. You might as well fish in your bath if you're going to fish like that. So so having this refuge area, and obviously it provides a massive benefit when we come to look at piscivorous predators. I'm not going to go into any great detail. Just we all know what they are. We all know the problems they cause, and by removing habitat, we make it a lot easier for these predators to target our fish. So that we'll leave that there. There's a time on other days for talking about predation and management of predation, but shelter and refuge is really important. Same applies here. This is a picture from a fishery actually close to me, a majestic fishery in East Yorkshire. This was an overhanging tree that was in the water in their root system in the winter. And you can see how these fish are all big, double figure, 20-pound fish, and they're all crammed underneath that bit of habitat. A bit of security there. It's cover, it's dark, and obviously you've got safety in numbers. And you can also see, this is the picture of the scuba diver, is the same water, and you can see how rich it is and how you've got this covering of plants on the bottom, but you can clearly see the feeding spots where the carp have been grubbing around for invertebrates in amongst the plant life, and they've cleared it of any of the plants. So also in here, obviously, shelter and refuge, artificial refuges, excellent cover and sanctuary, also have a good benefit for water quality, and you can make these cheaply yourself if you haven't got the habitat. And here's a really good one that was produced by Ramsbottom Angling Club over in the Northwest. It's one of the best I've ever seen. I think it took them 2 or 3 goes to really nail the design, but now they've done it. It's rich. It's got lots of different plants on there. What you may be able to just make out in here as well is they've got a grid on there which prevents prevented the birds from getting on there and grubbing around and eating the shoots before they become established. They're weighted so they're held in place, and they had a real benefit both in water quality, but also in shelter from particularly in this instance from avian predators, and it adds that that aesthetic appeal for the anglers. Goes without saying, invertebrates, bugs need somewhere to feed and to live themselves, and where you have plants and you also have bugs. And we've actually shown, the research shows that 5 times the biomass of invertebrates in submerged aquatic vegetation than on bare substrate. So it does show that having plants in there generates invertebrates, and invertebrates are free food. If you've got the inverts in there, then you've got something for your fish to feed on, and it gives them a free meal, if you like. And again, we don't need to major on this, but just a generalized food web, and you can see your filamentous algae and your macrophytes are down here, and how they support the various levels as you go up the chain, if you like, within this food web. So pond snails into larger predatory invertebrates, into the pike. I mean, you could put roach in here as well, and then eventually, obviously, at the end of the very top of the food chain, you've got your higher predators, your herons. Or you could put otter, cormorant, whatever you like up here. But it shows it all starts from here: bit of sunlight, bit of energy, algae and macrophytes, and we end up at the top of the food chain. So looking at the bottom of the food chain, we've got the smaller zooplankton, your Daphnia and such like, which actually depend on the algae as a food source, and you can see that quite clearly here. The full digestive system of this zooplankton is green with algae. I just really wanted to show how this establishes. This is a little back garden test or experiment, if you like, that a colleague of ours, Ian Welby, did. It's just a white bucket full of water, and basically it's just a time lapse over many weeks to show how those algae will come in and will establish themselves quite naturally if you leave it alone, and then over time you'll get zooplankton in there as well. And the benefit, of course, here is that this is a great food source for our roach and such like. And that's the sort of the final stage, and you can see how it's greened up nicely. And then again, so you've got the algae, you've got the zooplankton feeding quite clearly on that, and then again, this is an excellent food source for our cyprinids. And once that's exhausted, then we need to think about how are these fish being fed. So we need some supplementary feeding in there. Some other benefits, of course, to having vegetation, particularly bankside vegetation. Plant roots help to bind the soil together. They can prevent this slumping that we're seeing here, but this often is this erosion generated through things like paddle wheel aerators on soft friable banks can certainly cause this sort of erosion. So having some planting on there would certainly help. And this can sort of take many forms. This is your brushwood bundles, braiding and held together with some stakes, backfilled with some geotextile. And this is the sort of thing we can start to see. So here you've got on the left, we've actually got that these overhanging cages, which are helping to protect the plants till they become established, keeps the geese and such like off them, and allows the plants to become established. They'll grow through that cage, and you can either leave it on or you can take it off once it's done its job. And then just another example. This is one local to me. So the upper picture here is my local park lake, and you can clearly see how the bank is revetted with wooden stakes and some boards to keep it in. And what we actually saw there was this was erosion caused a lot by dog walkers chucking sticks in for their dogs, and the dogs careering out and just eating away at the bank, which brought it obviously became dangerous for other park users and started to nibble away at that path there. And the bottom picture is the West Beck and some work I did quite a few years ago now. But what you've got here is you've got some green engineering. It's a spile protected bank, top filled with soil, and then rather than leaving it with bare soil, what we did was we just oversowed it with a wildflower mix, and you get this lovely. Not only does it look very pretty, but it also adds a lot to the overall ecology of the river. So we get lots of bugs and terrestrial aquatic terrestrial invertebrates on there, but you've also got this nice shaggy margin here, which allows the aquatic inverts to be able to come out and to hatch. And what we also saw was this is much loved by things like water voles as well. Move a bit further down the river. This is the lower river hull, and you can see here how the difference between two areas. To the right of the fence, the cattle get free rein on the pasture land. To the left of the fence, they don't, and you can see how you've got that nice established margin. In this case, it's Phragmites, but where the cattle get in, that Phragmites is very rapidly exhausted. Fisheries that are open to anglers. When I actually saw the one on the top right, initially I thought it was a stock pond until I went and had a look around, and it isn't. It's a 22-peg fishery. And this is really, what we're trying to avoid here. These are just terrible habitats for fish. All right, yes, you could say there's some establishing marginal vegetation here, but it's not doing a great deal. And when you have to put road planings down to work through the mud, one would suggest it's maybe not established enough in order to allow fishing. But can we go too far? And we all, I'm sure, know that this gentleman is in here, the late John Wilson, and actually this is his fishery that he had in Norfolk, which has appeared many times on his TV programs. Look at that picture and then think to yourself, could our anglers that are coming, our club members or our dating anglers, would they be able to maximise that water? Could they catch fish safely and get them out of that area safely? Is that just too much for the anglers that we see? It might be a question that you need to ask yourself. Right. So just to finish then, really some benefits, some additional benefits to having aquatic plant. Dissolved oxygen. I'm not sure I don't need to go through the benefits. Plants photosynthesize, aquatic plants photosynthesize. A byproduct of that is oxygen. And we need, obviously, fish need oxygen in which to survive, and plants are one way of us putting that oxygen into the water. And I would certainly recommend you buy yourselves a dissolved oxygen meter and get used to using it and learn to use it and learn how to record and spot trends in dissolved oxygen over a 24-hour period. It's amazing how many fisheries don't have a dissolved oxygen meter, yet they'll happily spend £4,000, £5,000, £10,000 a year on stocking fish. Yet they're not armed to actually test the quality of their water. So just to show really why that's important and why it's important to get into the habit of looking at dissolved oxygen. Dissolved oxygen, it goes through a process which we call diurnal fluctuation. So it alters between dawn and dusk, with the lowest oxygen concentrations seen at dawn, obviously as plants can't photosynthesize on the night, so that process is reversed. So you start to see this lag in oxygen as the night passes, and you actually find that your critical levels for fish can be reached sort of at 4 a.m. in the morning, particularly in the summer months. So this is where you need to get your dissolved oxygen meter and start to record. There's no point going out here in the middle of the day and you think, everything's tickety-boo. When you're in bed, your fish are being compromised because your oxygen levels have fallen quite low. So one final benefit really here is that management of pollutants, or if you like, so that the ammonia and nitrogen cycle within a fishery. So ammonia produces a byproduct or a waste product of breakdown of protein by fish. It's highly toxic. That's broken down by nitrobacteria into nitrite, which is sort of medium toxicity. It's still toxic, but not at the levels that ammonia is. And then the final process here is that breaking down into nitrate, which is a much lower toxicity, many times less toxic than ammonia and nitrite. And the bit to highlight here is that nitrate can then be used by plants for growth. Nitrogen is a plant fertilizer, can then be used by growth. So if you've got plants in there, they'll neutralize and take up that nitrate and put it into growth rather than leaving it in the water to be to grow in toxicity. So just to finish then, I know I have gone a little bit over. I'm presenting, I should have stayed to time, but I apologize. So what's the key to a balanced fishery? Really, it's that effective holistic management, getting everything in balance, making you have everything in place, and no one thing can take over and compromise the health and well-being of your fish, and also the other animals and that are reliant on the water. So at that, I will say thank you for listening, and we will take any questions. Thank you very much.
Well, there we go. Thank you all for listening. I hope you enjoyed the talk and managed to pick up a few points or get a little bit from that. Have we any questions? Anything anybody wants to ask at that point, or shall we move on to Bernice and we'll pick up the questions at the end of this little session? Ian, is any?
Nothing's come in through the chat. Paul.
I must have answered everything in the presentation. How good was that? Well, if anybody else got any questions or anything they want to raise as we move on, then we can obviously we can do that, and we can pick them up at the end of this little session of talks. Right, I shall hand over to Bernice Brewster, who's our next speaker, and Bernice is going to look at algae and the impacts and potential management of algae within our fisheries. Bernice, over to you.
Here we are. Oh, you got a question there?
Oh, have it. Oh, crikey. Oh, for that. Ammonia, ammonia toxicity is an interesting one, because ammonia can become more toxic depending on the concentration of other elements within the water, so particularly pH and such like. But yeah, ammonia absolutely it will build up over time, and if you don't actually do something to counter it, then ammonia toxicity is absolutely something you could see. It's very rare to see really highly elevated levels of ammonia within fisheries. If any of you have ever kept fish in fish tanks, then you'll know about they're often referred to as new tank or problems, or new tank disease, when your ammonia toxicity builds up before your filtration systems are established. But I think unless you've got really high density fisheries, or you've got fish that are crowded in particular areas. It's quite rare to see really elevated levels of ammonia. We have seen it with external ammonia coming into fisheries from industrial agricultural sources as well. So that is another way that it can get in, but thankfully that is quite rare. Another question: which weeds are best for oxygenating the water? It's very much a case by case, fishery by fishery base. You've got to try and realize that what's the opportunities for management of the vegetation once you've put it in, and I would always advise when you're looking at this is to think about where you want to have your vegetation. Is it going to be an impact if it was to creep and get away from you a little bit? What, are you able to manage it? What areas do you want to add it into? Is it going to compromise your anglers? And have you got the means to actually manage and control it if it was to become a little bit problematic? And I think always one of the things we would say as well is stick to native plants that that are in your local area and that are suited to the conditions that you're dealing with. So the next question, Aid Green, we will answer that one, I think, in the presentation from Mike after Bernice. So we'll come back to that one if we may. Bernice?
Yes.
Over to you.
Okay. Let me share my screen. Can't find it.
Should have it at the bottom there. Share screen, and then if you...
Yeah, I've got share screen. I can't find the presentation.
Should be there, is on there.
Can't find it. Do you want to run the video then? I can't find the... Yeah, okay. Run the video.
Run the video. I can do that.
I can't see this at the moment.
Sorry. I've got it. All right.
Okay.
Super. Ready, Benny? Right, there we go.
Hello, I'm Bernice Brewster. I'm here today to give a presentation on algae. Algae are becoming increasingly common on many fisheries, but they also occur in all clear waters, and they also occur in rivers and in many ponds and lakes in the freshwater environment. We tend to think of them as being more freshwater, but of course they do occur in the marine environment as well. So let's take a look at what exactly we mean by algae. This is just a large convenience to call these organisms algae. They're not necessarily microscopic. They vary up to the giant kelps and the sea lettuce. So in the marine environment. So these algae are vary in size, they vary in color, they vary in shape. And grouping them together is just a convenience. The only thing that holds the group as a whole together is the fact that they use energy from sunlight and carbon dioxide to produce sugars. This is a process which is known as photosynthesis. Earlier, I said that algae occur in all freshwater environments. This is very true. We will even find them in the clearest of waters. So the lakes that are very clear, even though they appear to not have any algae, most of them do. I mean, they can have lots of other higher plants, the pond weeds, which are growing in the water, but you will still find that there are algae present in the water column. So what are we looking at when we look at algae? Well, they come in different colors. There are green, which is probably most familiar to many of the fisheries, that water turns a slight green color, especially in the summer. But one of the things to bear in mind is that with the milder winters that we have now, many of these algae blooms, that the algae start getting going much earlier in the year. When we have very icy and cold conditions, it really does cut back the algae blooms, and it takes them a lot longer to flourish. Whereas when we're having much milder conditions, you tend to find that the algae blooms start much earlier in the spring. So green blooms, yellow green, and golden brown, brown, red, and blue green. So a whole variety, almost a rainbow color of algae that we can find that occur in fresh waters. If we take a closer look at some of these green algae, Here you can see there's microactinium, there's volvox and eudarina. The interesting thing about algae is that we tend to think of them as being very static, tend to think that they're just in one place in the water column, but actually they move around. And microactinium, if you have a look at that, you can see that it has tiny spines on the edge of the colonies. And these spines help to make it buoyant, and they help to hold a place in the water column, so that as the algae becomes, it starts producing more sugars, it tends to sink a bit, and as it uses up the sugars, it tends to float, but the spines help to hold it in place. Volvox is a very large green alga, and it has tiny hairs on the surface of the colonies, which helped the algae to swim through the water, so it can actually get to the surface, use the sunlight, and produce more sugars. So there's, if you like, almost like a race for the different species of algae to get to the water surface to get the most of the sunshine. And then there's eudarina. Now this uses a gel. Obviously gels help to make the algae more buoyant and help to keep it at the surface. And this swims by means of tiny hairs, and these help to propel these algae through the water. There's also blanket weed, and as you can see from here, the blanket weed is a very fibrous nature. It's also known as silkweed, and these can be really devastating if they get onto a fishery. Because of the fibrous nature, it can actually make the site completely unfishable when it coats the water surface. It forms a mat, it grows very, very quickly, and usually, I'm afraid, the only way that you can effectively get rid of it is through some form of mechanical means. So it is a nuisance when it gets prolific on any fishery. We also have brown water. This is quite common in the spring, where you get brown waters forming, and often it can be mistaken for a sort of silty appearance in the water. It can also be slightly golden, and you can see Dinobrion on the left there. This has tiny little hairs that helps it to swim through the water. And you have Synedra. These are, Synedra is one of the diatoms, and they tend to glide through the water. You tend to find groups of them together gliding through the water, but certainly very prolific, often in the spring. The final type of bacteria, of algae that I've got here, are the cyanobacteria. They're not really classified now as true algae. They're more closely related to bacteria for various reasons that we won't bother with here. So they're not true algae. They tend to occur in waters where there really is a very, very high nutrient content. So these are technically called either eutrophic or hypereutrophic waters. One of the other things is that they are extremely toxic to mammals. In fact, one of these groups of cyanobacteria produces the most poisonous substance known to science. So these are very, very toxic. So it's worth bearing in mind, if you have blue-green algae blooms, that there is a problem there. It's also toxic to many of the wildfowl chicks. So where these occur on nature reserves, these cause a huge problem. And they have buoyancy mechanisms. You can see on the Anabina there's a tiny little circle in the middle of the algal thread. And this little circle is a buoyancy mechanism. During the hours of daylight, the algae produces lots of sugars, which are used to fill that little circle, that little cell, special cell. And that means that as it fills with sugars, the blue-green algae tend to sink. As they use up the sugars through the daytime or even through the night, the little buoyancy mechanism shrinks and up it comes to the surface. So this is a buoyancy mechanism helping to regulate where the algae is in the water. So very, very useful. Okay. As we're talking about blue-green algae, perhaps one of the things that we should mention is it's a problem if you can see it. Then usually if you can see a blue-green algae bloom, then that means there are probably thousands of cells present. The mechanism that we use if there's a suspected blue-green algae, or we want to know how potentially serious it is to use this Sedgwick rafter cell there that you can see. And basically this has tiny little squares in it, and we can count the numbers of algae per microliter or per milliliter. So very useful piece of kit. And if we do the cell count, as you can see from there, 20,000 cells per milliliter. So a milliliter is a very small amount of liquid. It has a short-term potential health risk. So there may be a skin rash or upset tummies, things like that. When you start to get to 100,000 cells per mil, there are potentials for long-term health risks. Certainly, blue-green algae are neurotoxins, so they can affect the nervous system. They can affect the liver. So they are nasty things. And cyanobacterial scums, they have the potential for acute poisoning and very long-term health risks. So it is worth being aware if you have a blue-green algae bloom on your lake, on your fishery, that you need to be a little cautious with it. Whilst we're very conscious of blue-green algae blooms, and we tend to think of them as unpleasant things, then we have to also bear in mind that blue-green algae were the origins of oxygen on the planet. So whilst they have a bad effect, there was originally, we have to thank them for the amount of oxygen that we have on Earth. So not all bad. Okay. I mentioned earlier that even on a clear lake, you'll find algae in the water, actually in the water column. Well, you know, it's quite important that in those lakes, there's a diversity, a balanced ecosystem. And that's what we rely on when we're keeping waters clear of algae. The problem is that not always does the balance maintain itself, and then you start to get the problems where algae bloom. In every lake, you have things like the water fleas, the rotifers, and these either feed directly on the algae, or so they are microscopic grazers, or you find that there are predators present and they feed on the water fleas and other grazing aquatic life. And then, of course, the larger predators, they will feed on the rotifers and on the smaller, the mayflies and other things which are feeding on, the mayflies will feed on the algae and on the Cladocera. Okay, if we have an unbalanced ecosystem, if it becomes disturbed, then we might lose all the grazers, which in turn affects the numbers of predators. And at that point is when the balance is in favor of an algae bloom. And of course, we very much know that algae blooms discolor the water. There's also quite a lot of evidence that algae blooms can enhance the spread of certain fish parasites, certainly things like flukes. When I mean flukes, I'm not talking about gill or skin flukes. I'm talking about the flukes that live in the intestine and other areas of the fish. So algae blooms can have a knock-on effect, and it's really better to try and have a balanced ecosystem than when we have green water or brown water associated with an algae bloom. What allows algae to thrive? Well, that's a very good question. The first thing is they love warm water. They really enjoy warm water. So if a lake is shallow or a pond is shallow, it's the perfect environment for any algae to thrive because it's nice and warm. The second thing is they like still water. We've seen that some of the algae have buoyancy mechanisms. They can move around in the water. And obviously, they're quite small and they need to move against the currents. So if you have a lake that's very exposed with lots of wind on it, it tends to dissipate the algae. They can't get to the surface, and therefore you have an effect associated with water movement. So if you have a lake that's surrounded by trees and shrubbery, it's still water, they love that. It's the perfect environment for them. Intense sunlight. Increasingly, we get periods where the sunlight is very intense. We may get periods of rain, but intense sunlight is perfect. And especially through the summertime, when the days are very long, if you think that probably in the height of the summer, we can have sunlight from maybe 3 o'clock in the morning right through to 10, 11 o'clock at night. And if it's a very, very sunny day, then the algae will make the most of the sunlight when it happens. The next thing that they need is nutrients. Well, there's lots of nutrients in the water and in the sediments, especially when we've got lots of fish in the system. So they do enjoy plenty of food there. Nutrients are important to them, micronutrients. And so that's another factor which will cause them to thrive. Algae undertake something called luxury feeding. And when we're talking about luxury feeding, they utilize all the micronutrients that they need. They'll take far more than they actually need. They become quite greedy. And so they'll absorb them. And when they do that, they can reach a stage where certain nutrients are no longer present in the water. And as a consequence of that, you start to get what's known as the boom and bust. So you have an algae bloom which absolutely thrives. It takes out all the nutrients in the water, and then you get the bust situation where they all die back, and that can lead to oxygen problems when you get a very sudden and significant dieback of algae. So it's worth bearing in mind, and especially if it's a very still water. Nitrate. This is one of the nutrients that certainly algae need. And it's a little bit of a problematic topic, I suppose. Nitrate we tend to associate with fertilizers and finding their way in through agricultural runoff. Certainly that is one of the ways that nitrate can get into the water system. However, it's becoming increasingly obvious that in addition to runoff, nitrate can also, when it's applied as a fertilizer, initially is soaked into the soil, but then over a period of time becomes dried, becomes into the atmosphere, and certainly associated with fertilizers, farm fertilizers. Once the nitrate gets back into the atmosphere, it can be dispersed over hundreds of miles. So potentially, even if you're miles away from the nearest agricultural center, nitrate can still infiltrate as the rain falls and drops nitrate back into the water. So there are issues with nitrate. If you're unfortunate enough to have a lake near one of the many motorway systems, you may also have come across a substance called NOx. This is basically nitrogen oxides, and they are given off with car fumes. And again, this can lead to localized nitrate pollution. Certainly, it tends to be localized when it's near a motorway. For some reason, these aerosols don't form. Phosphate. Increasingly, the phosphate concentration in water seems to be going up. This may well be associated with, again, fertilizer use, local runoff. And of course, one of the things that we should remember is that many of our lakes are on old estate grounds, and there are plenty of the old clay pipes which were used for draining the ground, which do feed water into the lakes over a period of time, and particularly when we've had very heavy rain. So phosphate is an important nutrient for algae, but it's also the limiting factor. When we talk about the limiting factor, what we actually mean is it's the one thing that's usually in very low concentration in the environment. And where there's plenty of it, then suddenly the algae can thrive. But usually it's the one thing that's in limited supply, except these days it seems to be becoming more common. So when we have high nitrate and phosphate concentrations in the water, we talk about these systems as becoming eutrophic. I'm sure you've seen this mentioned many times, either in terms of fisheries or even in the press, that waters are becoming increasingly eutrophic. Well, this simply means that they're becoming nutrient enriched. We've also gone one step further now, and we're talking about hypereutrophication. So where we're talking about hypereutrophication, we really are talking about a large concentration of both phosphate and nitrate in the water, and leading to algae blooms, and certainly in many areas on lakes, nature reserves, hypereutrophication is actually the biggest problem rather than eutrophication. So what are the common causes of eutrophication? Well, if you run a fishery, carp and bream are very common causes of eutrophication. Both feed by mumbling, feeding on the sediments, and when they feed in the sediments, they tend to release phosphate back into the water column. So if you had a lake where there were very few carp and bream, then the phosphate will become locked into the sediment, and it won't allow, it becomes chemically locked into the sediment, and it doesn't go back into the water column. But unfortunately, because of the way carp and bream feed, they actually stir up the sediment on the bottom, and of course that allows the phosphate to get back into solution, and away we go with an algae bloom. Overstocking with fish. That's a very common cause of eutrophication. If there are too many fish, then basically we get a high volume of nutrients, not just because of the way they're feeding, but of course, obviously, you get waste from the fish, bait, other things that are going to decompose, and they will contribute to the amount of phosphate and nitrate in the water. So again, contributing to eutrophication. Increasingly, there are higher amounts of nitrogen and phosphate in fresh waters. Some of you may have seen recently in the press that the state of our rivers is not good. I'm sure many of you are aware of that. And of course, for many of us who have online lakes, if the rivers aren't good, then increasing amounts of nitrogen and phosphate are going to find their way into our lakes as well. The average increase of phosphate per year in many of our rivers is 0.7 milligrams per litre. Doesn't sound much, but actually that's quite a lot of phosphate getting into the water. Again, agricultural runoff, we've talked about fertilizers, but of course there's also the issues of, in some instances, cattle, where they're allowed to poach the banks and actually go into rivers. And of course they can lead to a spike in concentration of both ammonia and phosphate. So there are issues with agricultural runoff as well. Okay, one of the other things that we shouldn't forget, and I am increasingly seeing, is sewage contamination. Sewage contamination, although it's largely treated, there's still a large amount of nitrate and phosphate that enters the water system. And we should also remember that in many rural areas, the bioreactors, the liquor that comes out of the bioreactors is usually very high in phosphate and in nitrogen too. So sewage contamination is becoming more common. I think probably last year, I've seen 3 separate sites, one of which was a fish farm, where sewage contamination was the main problem. So this is becoming a bit of an issue. It's a great shame that it's not taken more seriously by many of the water authorities. So sewage contamination will also contribute to nitrogen and phosphate. Not only will it contribute to nitrogen and phosphate, but of course there are the issues of ammonia as well. So big problems. And just because I'm on the subject, where there's sewage contamination, there's also issues surrounding prescription and recreational drugs, which have an effect on the environment, the aquatic environment as well. Okay, so we've talked about the blooms, the what they do, but how do they affect a fishery? So let's have a quick look at what happens when you've got a significant algae bloom on a fishery. The first thing is it depends on the intensity of the bloom. If it's a very significant algae bloom, it will have an effect. When it's in the summertime and you've got very high light intensity, very strong sunlight, the algae will produce lots of oxygen. We shouldn't really knock algae too much because they may well play, especially in those fisheries that are very heavily stocked, they may well play quite an important role in actually adding oxygen to the water, certainly through the hours of daytime. But we'll also come back on to what happens as you get later in the year and the days are getting shorter, then obviously light intensity and the availability of oxygen can be reversed as the algae will consume oxygen overnight and give off carbon dioxide. And as a consequence of that, you can get fish kills arising from an intense algae bloom simply because the algae can't produce enough oxygen overnight because the nights are longer. So we're looking at bloom intensity. We're looking at the amount of oxygen that the algae can produce. In the height of summer, algae can really be working, and it's a sunny, very sunny day. Algae can be working at maximum intensity, and you can find that the oxygen levels in the water can really rocket right up. Certainly, I've seen 150, 160% saturation. Actually, we don't need to worry about the amount of oxygen in the water. 300% is the marker at which fish will start to suffer from supersaturation with oxygen. Fry will suffer probably slightly less than 300%, but certainly for any fishery, you can start to approach 300%. It's not going to cause any harm to the fish. The biggest problem is usually low oxygen as a consequence of an algae bloom. So we've talked about light intensity, sunlight, very important. The algae blooms in the summer will really put loads of oxygen into the water. But you need to bear in mind as we get into the winter and we get the day length, the autumn time, and days are much shorter, that the algae can't put as much oxygen into the water. So monitoring dissolved oxygen is really, really important. The one thing I would say is that the dissolved oxygen meter is your absolute best friend. Okay, so we've talked about day length. One other factor that we regularly overlook is what happens when we have successive dull days in the summer. And what you need to bear in mind there is that during the dull days, the algae can't put as much oxygen into the water. When the weather is dull and overcast, particularly when it's continuous, so we have 4 or 5 days, 6 or 7 days in a row, where we just have heavy, cloudy weather, the algae are only going to be working at very low rate. And as a consequence of that, the oxygen content of the water will gradually drop off. So by the time you get to day 5 or day 7, the oxygen concentration in the water may be as low as 30%. So again, one of the most important things you can do through the summer, measure the dissolved oxygen in the water. Ideally, you want above 70% saturation. 50 to 70 is acceptable, but not brilliant. If it's anything below 50%, you need to think about aerating the water. Okay, not only do we have to consider the effects of oxygen, but certainly some species of algae can be quite harmful to fish, particularly when they're present in huge numbers. And algae can be present in huge numbers, which is why the water becomes discolored. So here's a few of the species which cause problems to fish. These are commonly termed as spiky algae. As you can see, they have sharp points on either end, or they have a sharp point. And these tend to affect the gills. What's happening is poor old fish, as they're breathing in these algae, which are scratching the gills. And that leads to quite significant damage to the gills, which are extremely delicate. And as a consequence of that, it can end up causing quite significant mortalities just simply through an algae bloom with spiky algae. So it is worth bearing in mind that if you do have algae blooms, it's better to try and control it rather than wait for the fish to have problems with spiky algae. There are also some species which are significantly toxic to fish. Euglena sanguinea, it actually turns the water a bright red. As the name sanguinea would imply, it sounds like blood, and it does indeed turn the water where they're present really bright red. They all produce something called Euglena ficin, and that's extremely toxic to the fish. So if you get a red algae bloom, you need to deal with it quickly, otherwise you will get some fish mortalities. And this one, Primnesium, is it an algae? Well, it's coloured like algae. However, it does cause major fish mortalities. It seems to have a toxin, but certainly where I've seen it present, it's not only producing a toxin, but it actually is almost parasitic on the gills and on the soft tissues of the fish. It's quite amazing that it seems to actually be feeding in some way on the fish. Previously, Primnesium has always been associated with brackish water or water that has a slightly saline content. However, don't be fooled by that, because Primnesium can occur in some fresh waters, obviously where there's a certain mineral present, but be aware that Primnesium is a killer. So what do? We know we've got an algae bloom. How are we going to control it? The first thing to do is, if you have got an algae bloom, if you are checking the water for dissolved oxygen, obviously if the oxygen starts to dip, the first thing you're going to do is introduce aeration. I think probably most fisheries these days have some form of aeration, and if the worst comes to the worst, you can always just put a water pump onto the water and just spray the water in. It will certainly do something, not necessarily aerate the water efficiently. Wind shadows. Everyone loves a fishery that looks very enclosed and idyllic, but actually wind shadows, where the wind can't get onto the surface of the water, you tend to find the water is very still, and as a consequence of that, the algae just thrive. They love these still waters. So wind shadows, you don't have to cut trees down. Nobody likes cutting trees down, but you can raise the crowns, or you can pollard them, which is the posh term of raising the crown. So cut away the lower branches, create open spaces so that the wind can get through. It may be surprising to learn that if the wind hits trees, it's like hitting a buffer, and it almost brings the wind to a complete halt. And it actually takes 3 times the height of the tree before the wind will drop back onto the water. So it is an issue. So wind shadows and raising the crowns or pollarding trees. Cut back shrubbery, that can help as well. Obviously, where you've got dense shrubbery, that's going to stop the wind from getting onto the water surface. Ideally, you want marginal and submergent planting. The more plants you have, aquatic plants that you have around the margins and actually on the lake itself, then these will absorb many of the nutrients, phosphate, ammonia, nitrogen. They will take them directly from the water and help to reduce the overall nutrient content of the water. So very, very important. And finally, cutting back and removing any dead reeds or rushes in the autumn time, because you don't want them falling back into the water and contributing to more release of nutrients into the water. The one thing that I haven't mentioned is reducing the fish population. If you've got a lot of fish in the water, worth reducing the population. Clear back the head of fish in the water, because again, fish are going to produce more waste, and they're going to contribute towards the nutrient content of the water. Okay, how do we control nuisance blooms? Well, the first thing is, previously we used to be able to use barley straw extract. Regrettably, under EU regulations, even though we're not in the EU anymore, barley straw extract can't be obtained, so you can't use that anymore technically. although a lot of people, I think, are producing their own barley straw extract. You can use barley straw. Barley straw is very, very efficient at controlling algae, which is why we use the extract. But of course, if you tip a whole bale of barley straw into the water, that's going to have no effect whatsoever other than to decompose and contribute to the nutrient content that you're trying to get rid of. So tipping a bale of barley straw, like you can see here, into the water doesn't work. Barley straw produces this extract, which does effectively kill algae blooms. But if you're going to do it and you're going to use the barley straw needs to be in sausages and at the water surface. That the mechanism that produces the barley straw extract is very oxygen loving. It's produced by bacteria and fungus that break down the barley straw, and they produce hydrogen peroxide. However, it will only work if there's plenty of oxygen around. And in a bale of straw, you're not going to get much oxygen in there. So if you're going to use barley straw, they need to be in sausages and they need to be on the water surface. And you need to put it in early. About now is about the best time to start using barley straw. And you can connect fishing floats. That's an ideal way to do it. I prefer to see fishing floats, and they're not very expensive. They're only a few pence each. I prefer the fishing floats to using old lemonade or milk bottles, because I think that looks extremely unsightly. However, so the sausages, put them on in now, and have a system of rotation. The barley straw extract lasts, it will be produced for about 6 weeks. It takes 2 or 3 weeks, depending on the water temperature, before the barley straw extract gets going. And then you need to allow, once the barley straw starts to decompose and has got to a certain stage, to renew it. So having some kind of cycling of barley straw is a great idea. Dyes, there are plenty of dyes available now. These will kill off the algae, but you need to bear in mind, if you're going to use a dye and you're going to kill off the algae, you need to measure the dissolved oxygen while you're doing it. Otherwise, you could get into big trouble if you cause a sudden dieback. So dyes, yes, they will work. Bacterial and enzyme preparations, there's quite a lot of these on the market now. And these are quite effective. The only thing is, because they're bacterial and enzyme preparations, they work in the summertime when the water temperature is high. They prefer warm water to cold water. If you put them in cold water, they won't work. Chalk products, again, these have been used particularly where there's been issues particularly associated with blanket weed or something like that. Sometimes they can ultimately lead to quite a significant bloom the following year. So chalk products, very good, but they can have a knock-on effect if they release nutrients from the sediment. Ultrasonic devices, some of the ones I've seen haven't been terribly successful. I've actually seen the algae kind of swimming in front of them. Whether there's a fault with the way the ultrasonic device has been installed or not, I don't know. Some people swear by them, some people swear at them. So for me, the jury's still out on ultrasonic devices, and it probably depends on the size and depth of your lake. Planting, I love plants. For me, using planting, marginal plants, iris, rushes, any kind of planting is better, is one of the way forwards for biologically controlling any algae bloom. Okay, essentially I've finished my talk on algae, but I thought I would throw this in as a final few slides. This is Azolla. Some of you will have seen it on fisheries. It's called fairy fern. This is what it looks like in close up. It's almost like a sort of duckweed, but it has very tiny, rather decorative leaves. It grows like wildfire. This is a lake I went to last year. I went there in July. And this is how it was in July. 2 weeks later, the whole lake was completely unfishable. because the azolla had covered it completely. Azolla was introduced by the Victorians. They became very keen on fish keeping and pond keeping. And when they finished with their azolla, I think it ended up probably in local ponds and lakes. However, sometimes you might find on your lake that you get an outbreak of azolla, the fairy fern. It's a nightmare. Give it the right conditions, it absolutely romps off. And as I say, this particular fishery became unfishable within 2 weeks of my visiting. However, one of the things that I did suggest was that we introduced a weevil. It's available from, can't remember at the moment, but I will put it on the notes afterwards. This weevil is Stenopelmus rufinaceus. It's a North American weevil. It doesn't survive in this country once it's chewed up all the azolla. And actually, this is looking at the same bank of reeds that were in the previous picture. And as you can see, this was in October of this last year. Given it a few months, and it had munched up a large proportion of the azolla. I can't say it had used up all the azolla. There still were some azolla around the margins. The only difficult thing with this particular site was that I went there in July, and the weevils, there was obviously a great demand for the weevils. There weren't quite enough weevils to treat the entire lake. And also they went in very late. So by October, although they had done a sterling job of clearing up the azolla, earlier this year, there was a bit of a regrowth of azolla on the site. So, bearing in mind when you can get the weevil in is quite important. So it will work. It does a sterling job. We are told that the weevil will overwinter. I'm guessing that it was just a bit cold, which has allowed the azolla a bit of a comeback. However, it has worked, and we are expecting that the azolla will be completely munched up through the summertime. So a real success story with biological control, well worth bearing in mind. And it's actually the organisation that produces the weevils. They actually breed them ready for the onslaught of the azolla, is the CABI. I will ensure that there are links to CABI and how to get hold of the weevils if you get azolla on your fishery. So that's me, I'm finished. Just to say, there's no such thing as a dumb question, except if it goes unasked. If you have any questions, I'm more than happy to take them. If you're concerned about your question sounding a bit silly, you can always email me. All my details are given there. Thank you for listening. Goodbye.
Excellent. Thank you, Bernice.
Sorry, overran.
Oh, no, you're absolutely fine. All really interesting and good stuff. And the weevils at the end, particularly. That's a serious job they've done there, isn't it? Controlling the azolla.
Yeah.
Just whilst there's a few questions coming to the chat. Where are we? We'll start at the top.
1404, Dennis.
Go on then, Ian. You're following me now where we are.
Okay, so first one's from Dennis, saying water samples we've taken from our lake and tested show levels of nitrates and phosphates, both of which we understand contribute to algal blooms. As levels are low and our Daphnia levels seem good, what other factors contribute to these blooms, especially Synedra species, which may aggravate our trout stocks? Our lake has not cleared this winter. Phosphate and ammonia readings taken by Hannah, etc. equipment last Thursday. And also, any public information on which algae cannot be predated upon by Daphnia?
Even when phosphate and nitrate levels seem to be low, they can still be high enough to support algae blooms, and especially things like the the Synedra and things like that at this time of the year. The diatoms. The only really way to do it is by planting aeration, if you keep the water well aerated and lots of water movement, that does help to disturb the algae. So I don't know if that answers the question.
Okay. Another one here from Matt. One of the first few photos of the waters in your presentation looks similar to a commercial carp water. Is this an algae issue, or, as I've previously thought, increased turbidity from large numbers of carp?
No, I mean, when you get some of these brown algae blooms, they really do look just like, sediment has gone into the water. So, it can be misleading. It can be misleading.
Okay.
Often, though, I would say that many of the algae blooms are associated with carp waters because of the way they feed.
Yeah, indeed. One here from Cheryl, talking about dye. I think that's been answered in your talk later after she asked the question. One from Eddie. I believe, how easy is it to identify a particular algae or cyanobacteria species currently, and what sort of timescale would you be talking about?
Algae themselves, really the only way you identify the algae that are on there is if you take a plankton sample, which is the common way to do it. Certainly with blue-green algae, if you can see them, you've got a problem. Mostly the blue-green algae are very, very obvious.
Okay, thank you. One from Paul. In the last week, lost fish to a suspected diatom outbreak. I blue dyed the water back in January, and I was due to apply barley straw extract at the start of April. Will both of these measures reduce the algae risk, or am I applying them too late?
No, they should do. The only problem is, as I said at the beginning of the presentation, that because we're getting much milder winters, the algae blooms seem to get going much earlier in the year. And therefore, perhaps we need to think about taking, measures such as using barley straw even earlier now, or even using some of the dyes, just starting to use them much earlier in the year.
Excellent. Are there any documented control methods for spiky algae specifically?
No, it's exactly the same as with any other algae. And again, certainly I would consider, putting on aeration if you think you've got an algae bloom, simply because they like to be near the surface. They like still water, and if you stir the water up, that's going to disperse them.
Excellent. Dom was passing on some experience there. Have had great success using Christmas tree netting for barley straws.
Yes, that's a great favourite of mine as well.
And or onion sacks.
Onion sacks, yeah.
Another one, Eddie. How and why do chalk products release phosphate?
It depends very much on the type of sediment that the chalk products get used for. There's two types of sediment. One is mineral, and the chalk products have no effect against those whatsoever. However, if you've got a lot of organic sediment, the chalk products help to break down the organic material, and as they do so, they can release some nutrients back into the water.
Okay. One from Mick. Hi all. Regarding blue lake dye, the flow rate into our lake is around 5 litres a second. Do you have any case studies or instances similar as to how long it lasts when treated? We're in the process of wanting to treat our lake, but we can't find any data regarding inflow rates.
I don't think I've ever seen anything about flow rates. Perhaps the answer is contact the manufacturers and ask their opinion. There should be a technical department that might be able to help you with that. But obviously, if you've got incoming water, it is going to dissipate the dye much more quickly.
Yeah. Okay. One from Matt. In terms of planting, where can these be sourced from, and are there any subject to some form of control, like movement of fish?
Well, the first thing I would say is that don't go to any aquatic store. There are various plant suppliers, specialist aquatic suppliers. I don't mean ornamental. I don't mean, for the pond or anything else. They specifically supply plants for for planting into lakes. There are a few around. I don't know if I'm allowed to mention them, so I won't. But there are quite a few different suppliers of plants specifically for lakes and other the aquatic environment.
Right, thank you. I think we'll just leave it there, Ian, if we may. So just slightly conscious of time, and we've got 15 minutes or so at the end to pick up on the none of the other questions. But thank you for everybody for posing those questions. Some really good ones there. But if anybody wants to share any thoughts or wants to answer any questions or give any experiences of their own, if you put that in the chat function, then everybody else will be able to see it. And Bernice, maybe we'll maybe have a minute just to flick through some of the ones that we maybe haven't answered. I noticed John Reed's on as well, one of our speakers after the break, and he's answering a few questions as well. So thank you for that. Super, thank you, Bernice. Another really interesting presentation and topic as always. Right, so our final speaker before we have a quick break is Mike Stretton from Aquatic Solutions UK, and he is going to talk to us about mechanical control and mechanical management of vegetation within our fisheries. So I will share my screen. It is recorded. Where are we? Oh, that one there. And we'll have a listen to Mike.
Hello everyone, my name is Mike Stretton and I'm going to talk to you about the mechanical options for the many issues that you may have with aquatic weed. Just a little background on myself. I run a company called Aquatic Solutions UK, which is very much a family business based in Rugby, Warwickshire. We cover the whole of the UK though, operating a fleet of trucks or amphibious machines. We started out as contractors in the farming industry probably 40 years ago and have diversified into aquatics some 12 years ago. Our customers are varied and many, from angling clubs to the MOD, on both commercial and residential water bodies, and we work on everything from ponds to nature reserves. These are our amphibious truck saw machines that we operate, and we have a vast array of attachments which enable us to do almost every job that is asked of us. Some of the most common services that we offer are aquatic weed cutting, dredging, water lily, bulrush, reed removal, bank repairs, and many more. So, weed control. There are various methods of keeping the aquatic weed in your pond or lake under control. Mechanical control is often the only solution now that chemicals such as diclofenac have been banned. Mechanical control can be used to target specific areas, and it does provide an immediate solution. Specialist machines can remove the vegetation from the water body, preventing the material from sinking to the bottom and decaying. Mechanical weed cutting does not kill the plants, so the oxygenating properties of the plants are still retained. There are various aquatic weeds. Some are more invasive and problematic to your lake or pond than others. Cutting aquatic weed provides an instant solution to overgrowth, allowing your fishery to continue to run efficiently. Best practice is for the removed weed to be left on the bank for 24 to 48 hours to allow the pond life to find its way back to the water. Cutting does not guarantee a long-term solution. Certain weeds can recover in a matter of weeks. However, regular cutting can reduce the plant's recovery and thus reduce the regrowth. There is a theory that if the weed is cut on a very regular basis before it reaches sunlight, that it will simply run out of steam and die. But this is obviously a very costly operation, so not really viable to do. What are my options? Hand rakes, cheap to buy, cost typically between 20 and 150 pounds. They're obviously easy to use and ideal for swims and small areas, but they are extremely portable and handy to have around. Downside is they're very labour intensive, can be time consuming with very little removed at the end of the day. The weed does need to be removed manually and there may be not much reward for a lot of effort. You also have to be careful that you don't drag the weed into a previously clear patch. And they are difficult to use from a boat. Another option is a boat side cutter. They can cut considerably larger area than a hand rake. And they are relatively cheap, being £1,500 to £5,500 with low running costs. Downside is you are restricted by cutting depth, and the cut weed still needs to be removed. This could be considerable and is very labour intensive to remove these large volumes of weed from the water by hand. After cutting, you still have to remove the weed by hand, and you may have to wait till it drifts to the water's edge to enable it to be removed properly. The wind can be your friend or enemy if it is blowing in the wrong direction and your cut weed ends up at the wrong bank. So take into account the wind direction before cutting. Contractor supplied machines. Benefits of these are they're efficient and large areas can be cut and cleared quickly with minimal disruptions to fisheries. They come with experienced operators and huge volumes can be removed. Some machines are amphibious, such as ours, and cost around £750 to £850 a day. Cons, there is a high cost of ownership and they can be difficult to get hold of in busy periods, especially during the summer. And you will have unsightly piles of weed on your banks due to the high volumes of weed removed. But then again, that's what they're there for. This is a typical lake being cleared of weed with one of our machines. These are the most common types of aquatic weed. There are many more, but these are what we are called in most to remove. Canadian pondweed. Probably one of the most common weeds found in ponds and lakes throughout the UK. It can be difficult to cut, especially if blanket weed is amongst it. Typically 1 to 2 acres per day will be cut and cleared to the bankside. Dense material, however, and large lakes will be nearer to 1 acre per day. If a machine has to travel from one end of a large lake to the other to bring the weed back to the bank, it is going to reduce productivity. So if possible, have several locations to deposit the weed around the lake. As with all aquatic weed, huge volumes can be growing under the water. Large piles can be problematic, so be prepared. It's amazing what the weed volumes can be under the water. 20 tonnes per acre can easily be expected. Cut weed can be taken away, but adds to the expense, so best avoid it if at all possible. Ideally, find a location on site to allow it to decompose away from the water. However, it quickly loses its bulk due to having a high water content, and a pile of weed that is piled head height can be reduced to the height of your knee, literally in a week or two's time when it starts to break down. This unfishable lake was clear in a matter of days, and 100 tonne of weed was cut and cleared. Curly waterweed, lagracythine, in my opinion, is probably one of the worst. It's extremely invasive. It's a totally submerged weed that is rooted in the silt and can grow in water 3 meters deep. It grows faster and outcompetes most native species. You'll see in the bottom of the picture here, there is another plant called water milfoil. This, I'm afraid, has got absolutely no chance as it's being swamped totally by the lagracythine. Fishing is virtually impossible, especially when it's established. It overwinters well and doesn't die back during the colder months. And it can increase the water's pH to over 10. Although an oxygenating plant, it can cause big fluctuations in the amount of oxygen available in the water, particularly at night when it starts pulling oxygen out of the water, resulting in finding fish kills in the morning. It's probably one of the most dense aquatic plants that we remove. Because the volumes are so great, it's possible only half an acre a day may be cut and cleared. If small patches are seen, pull them out by hand, if possible, before they can establish. It's quite distinctive, and you will see it, as it has a very tightly knit leaf structure. As with all aquatic weed, once cut, remove as much of the floating material as possible, and the cut weed needs to be removed onto the bank and deposit away from the water's edge to prevent it drifting off and regrowing. Once established, the sheer volume of the weed makes this nigh impossible to do by anything other than a specialist machine. Best practice, as always, is to leave the weed for 24 to 48 hours to allow the fauna to return to the water. Next one, curled pondweed, Potamogeton crispus. Definitely not as invasive as some. It's not as thick and dense when growing in the water, so it's not as problematic for fisheries. Less volume when cut and removed, and it has a short growing season, so you will find that it disappears quite quickly. We don't come across this as much as the others, and we don't get called upon to clear this as much, probably less than half a dozen times per year. And grass carp can have a controlling effect on this plant if you're allowed or want to introduce them, that is. Water milfoil. This grows in lakes and ponds, but not fast-flowing water. There are stems which emerge from the water, which are useful for dragonflies and damsels to lay their eggs. It does get going early in the year. It does require a lot of sunlight, which is why it can form such dense mats on the surface. And it can grow in deep water. Significant volumes of this are also produced from cutting. Occasionally, if cut too early, the cut vegetation will sink rather than float, making removal difficult. This is because the plant is not oxygenated sufficiently to make it buoyant. A simple way to test this is to pull some out by hand, leave it on the surface of the water and see if it floats or sinks. It reproduces by seed and vegetative growth, so control measures should take this into account. And it can grow back quickly in the right conditions. But using a dye, if you're able to, does slow regrowth. Hornwort, sometimes confused with water milfoil, but this has a denser appearance. Its leaf structure does provide good cover for newly hatched fish. It's without roots, but may attach itself to the bed of the water body and can often be raked out, avoiding the need for cutting. It dies back in the winter, but is fully hardy, so it does come back in the spring and can produce a significant volume of material. Water lily. So, not an anaconda, but a large section of root. The rhizomes on these plants can be huge and very extensive. They can form a mat of roots along the lake bed, which you can easily walk on. Eradication or control by herbicide spraying is difficult. It's possible, but difficult due to the amount of rhizome that the chemical needs to work on. If spraying with a herbicide, that leaf area here has to take in enough chemical to kill all of this root system. Very difficult. Cutting is extremely temporary and regrowth will show itself very quickly. The absolute best form of control is to get the root system removed. The majority can be taken out in the first year, but small sections left behind will still grow. So catch these early with herbicide or hand pull, as the root system is now small and loose. Any part of the root left behind will be small and much more easily killed by herbicide. Large piles of root matter can be expected. Imagine this amount of material rotting in your lake. If this was just sprayed with herbicide and left, you do not want to turn your lake into an underwater compost heap. It's a skilled operation to remove these rhizomes. Once scrubbed out, they float to the surface, ready to be removed. Due to the sheer volume of material, additional machines are often required to remove the vegetation out of the water. Obviously, the first year is going to be the biggest part of the operation, with the following years taking much less time as the biggest bulk of the material has already been removed. But long-term control of lilies can be achieved. Common reed, Phragmites. Phragmites are again particularly invasive and can grow very quickly, taking hold of small rivers, lakes and ponds. Phragmites have an extensive root system. As with the lilies, grubbing out the roots is the best way to control this plant. Mechanical cutting provides a short-term solution, but is significantly cheaper and quicker than removing the root system. To get the best results, however, if you are going to cut below the water line. This is so the water goes down the stems and it supposedly helps drown out the roots. In large reed beds, channel can be cut to aid fish movement if required, which in turn do help birds such as bittern, which are shy and like to feed away from human contact. Greater reed mace, commonly known incorrectly as bulrush. This grows in fairly shallow water and will spread across lakes and ponds if they are silted up. The roots will trap silt. This allows them to spread out into water that was previously too deep for them. Cutting is also extremely temporary with it. Remove them with the roots for much longer control. Avoid bird nesting season or check thoroughly for nesting birds before removing. If possible, remove this in the winter when the material is less bulky. If required, they can be contained behind a semi-permeable membrane such as Nicospam to prevent them from spreading, and the same can be said for Phragmites. Islands can be created and backfilled with silt from the lake. Bulrush is then contained within the island. This keeps the lake's biodiversity with the added benefit of removing some of the silt to create the island, so win-win. And the islands can be made to any size or shape. Broadleaf pondweed. This grows from a rhizome and grows in all depths of water. It's extremely invasive and very problematic. These can create dense surface cover, impeding fishing, and cutting alone will only offer very short-term solution, and this can come back in as little as 2 weeks. Applying herbicide to this is very difficult, and removing the structure is required for longer-term control. It's a very problematic plant. Control can be achieved, but definitely not in the first year, and it's also very time-consuming and expensive to do. Water soldier. And here you have a 20-acre lake that is absolutely full of it. It's also known as a pineapple plant because of its spiky leaf. It stays submerged for most of the year before popping up in the summer, flowering, and then sinking again when the water temperatures get colder. It is a sign, apparently, of healthy water. It reproduces very quickly and can soon take over a water body, though. It's a loosely rooted plant that can be easily moved with machinery, although sometimes its anchor roots will need to be cut first. Annual maintenance may be required to keep this at acceptable levels, but remove this in the summer when the majority of the plants are on the surface. Very large volumes can be expected, so additional machinery may be required to move it away from the bankside. But good results can be achieved relatively quickly. This here was a pond, and this was all cleared in a day. New Zealand pygmy-weed, often just known as crassula. This is another one that is extremely invasive and not one you want in your water. It can start growing on the banks, but spreads rapidly inwards. It grows in very thick carpet-like mats. If seen on the banks, spray with a herbicide or dig out very carefully. Like most aquatic plants, this is virtually impossible to eradicate. It can be removed with large volumes on the bank, but expect to do this every 2 to 3 years as it will colonize very quickly. It's an extremely dense material and not good for fish movement or fishing. But it can be cleared. This was a lake in Ireland that took just a day to clear. Water fern or azolla. Doesn't look much there, but again, it's not something you want in your water. The top picture is before clearing. Again, not fishable, but it can be cleared, and your bottom picture clearly shows just after we'd cleared it. It can be scooped up, but again, it will return. Weevils are a good form of control if you can get them, that is. If they're not ordered early enough, they may come too late for you. Blanket weed. This is probably one of the most troublesome and frustrating plants to deal with. When it's in full bloom, fishing is virtually impossible. It can cause fish kills by depleting oxygen. and it grows rapidly in sunny conditions. It's virtually impossible to cut, as it's just like cutting wet cotton wool. It can only be raked out, but this is only a temporary measure and it will just reappear during your next hot spell. When it dies back in the winter, there are masses of material rotting down and turning your lake into an underwater composting zone. Aeration, barley straw, dyes, ultrasonics and Foslock are all useful control measures though. The picture on the left shows us installing a floating island into a lake with blue dye in it. The pre-planted island was put in as an additional measure to introduce some extra plants that would compete with the algae for nutrients. And the picture on the right shows a typical high volume aerator, but unfortunately you do need electricity for something this powerful. Another option is Foslock, and I just want to spend a bit of time on this as it's something we have been looking into the past year. So what is Foslock? Foslock is a clay product developed in Australia, and this permanently binds available phosphates in water and sediments and reduces unwanted algae growth. One of the main sources of food for algae is phosphate, and Foslock literally locks this up in the water and sediments to deprive the algae of the supply it needs to grow. When algae dies back as a result of ultrasound or algicides, it releases phosphate back into the water, whereas Foslock removes the phosphate permanently. Phosphate bound to Foslock will never be released, even when oxygen levels drop or pH increases. It works quickly, binding phosphate in only a matter of hours, and it will continue to bind this phosphate until all its binding properties are used up. It comes in a granular form in bags, but ideally needs to be applied as a slurry evenly over the pond or lake. Sounds perfect? The downside is that it's expensive and not easy to apply. Up to now, it's been labour intensive and requires large floating pontoons to apply this correctly and makes it unviable for ponds and smaller lakes. Big barges or pontoons are required to stack the product on. Cranes and forklifts are often needed to load the big bags as well. This is okay for the large lakes, but it's not really useful for the smaller ones. So what can be done to reduce costs? It's a proven product, but expensive to apply. So, reduce the manpower involved, reduce the heavy machinery, reduce the setting up time, and simplify the water sampling procedure. So what have we done? We've done exactly that. We have made our own Foslock applicator designed specifically for the smaller lakes or ponds. It's just a two-man operation, one to drive and one to load. The loading man gets the bags ready while the machine is applying the Foslock in the water, and he fills the hopper up as soon as applicator returns to the bank. Turnaround times will be quick, and it will be more manoeuvrable than the big pontoons. There's no cranes or forklifts required, and it will also convert the Foslock granules to a slurry. And crucially, it will apply the product accurately. Hopefully, this makes the application of Foslock logistically possible for fisheries and more viable. Unfortunately, it's never going to be a cheap option, as the product is costly. It has to come all the way from Australia, but if you're paying a lot of money for it, do you really want to be just chucking out of a bucket from a boat? If phosphates are the problem in your water and it's causing you algae problems, this just may be the solution you need. Well, that concludes my presentation, everyone. I hope not too many of you have fallen asleep, and I would just like to say thank you for listening. But there's just one more request, which is, although this is an amusing slide, it does show the potential hazards of having dense weed below the water surface. So please be aware of this, particularly if fishing from a boat or your lake is prone to other people swimming in it. Take care, stay safe, and thank you for listening.
Excellent. Thank you for that, Mike. Mike isn't here today. I believe he's on holiday, but his son Tom has joined us to answer any questions that we may have. So, Tom, I know you are in the call, and Ian, have we any questions for Tom?
There's an observation from Richard first that the Weed Raker brand of rakes shown initially aren't available in the UK at the moment, only being supplied to French supplier. And I was just asking, any examples of the use of grass carp to control hornwort?
Yeah, grass carp can be an effective measure for certain types of weed. Can you hear me, by the way, Paul?
Yeah, go on, Tom. Yep, super. Thank you.
Yeah, so grass carp can be useful for certain types of weed. We don't sell grass carp. We don't sell fish in our bag, but we have seen examples of it. So yeah, I mean, if you speak to a suitable supplier of fish, they can help you out. But yes, it can be effective on certain types of weed. Hornwort is one, Canadian pondweed is another. So yeah, definitely worth investigating.
Just a point just to make, I think, on the grass carp question is they are a non-native species, so they are only limited on their on where they can be stocked in into particular types of water. So just do consult with your local EA officer, I think, before you go down that option. Sorry, I did you, Ian?
Yeah, no, they're certainly not the magic silver bullet people think they are. I've had them sort of eat stuff that you don't want them to eat, but there you go.
Absolutely.
Yeah. Let's have a look. What's the best time to remove the blanket weed mechanically? They've run into issues moving it in the summer, and I've had to have a similar company to yours try and remove them with truck saw, which was okay, but much was dropped.
I mean, there's no sort of right or wrong time to do it, really. It's whenever it becomes a problem to you. If it's stopping you obviously using your fishery, then obviously you need to get someone in and get it removed. So there is no right or wrong time to do it. It's really just when it becomes a problem for you. And maybe if you, it depends what you've got in the budget. If you can afford to have it removed once a year or twice a year, then obviously that would affect it. So yeah, there is no right or wrong time. It's a bit of a how long's a piece of string question, but yeah, when it's a problem to you, it is the right time, basically. I know that's not overly helpful, but that's just sort of the nature of it, I'm afraid. So yeah, if it's stopping you fishing, then yeah, give us a call or give somebody a call and we can have a look at it and see what we can do for you.
Excellent, thank you. One from Michael. We've got a small lake which over the last 18 months has had a major problem with hornwort. Is mechanical removal the best option?
Yeah, I mean, it's certainly an option. So I don't know what you say, small lakes. I don't know what size small is, but if it's a decent enough size and there's a fair old volume of weed in there, the mechanical removal would certainly be the quickest method for you, rather than, as Mike mentioned in the video, going in with hand rakes and that sort of thing. So mechanical removal is probably one of your better options, but as we've mentioned, it is only a short-term measure. So just bear in mind, it's not a magic solution to get rid of it. It might need sort of yearly cuts to keep on top of it, but it will keep on top of it, but it just will need regular attention.
Okay. Someone else asked a question regarding Phoslock, sort of indicating tests on Hatchmere in Cheshire and the mere in Knutsford show that phosphate can be released from Phoslock at a later date. Do you have any comments on that?
We're still sort of investigating the Phoslock, really. So we've done sort of smaller scale operations with it, and they've been successful. But the main contact we had with Phoslock has recently left the company, which has just slowed down things a little bit. But it's still an ongoing thing. It's still a bit of a learning curve for everybody, but it has proven to be very, very effective in the right cases. But it's one to look at on a case by case basis. You can't really just sort of say that it's a magic fix for everybody. It really does depend on later. But we can discuss all that with you if you're interested.
Excellent, thank you. And the last one was just another comment on grass carp, that they're obviously less effective when angling's present. But that's it, Paul, in the chat room.
Super. Thank you, Tom. Thank you for joining us. It's much appreciated. Yeah, if anybody's got any other questions, then please just carry on popping them in the chat. Right, we are as always with these things, the questions keep flowing and we go slightly over time, but we're a little bit behind, but we will still have a quick break. So if we just, it's what, 3:10 now. If we can be back for sort of 20 past-ish, and we'll try and make a start sort of there, 20 past, 25 past, and we'll make a start again. So we'll just have 10 minutes. There is there's no need to leave the meeting. If you just turn your cameras off and put yourselves on mute, and then we can come back in sort of 10-12 minutes or so, and we'll make a start with the second half of the workshop. So yeah, thanks everyone. We will see you in 10 minutes.